take a look at problem number 2 and dive a little deeper into the idea of this excess and limiting reactant. If we take a look, it says the black oxide of iron, Fe3O4, occurs in nature as the mineral magnetite. This substance can also be made in the laboratory by the reaction between red-hot iron and steam, according to the following balanced equation. Woo! 2 balanced equations in a row. This is when 36 grams of H2O is mixed with 167 grams of iron, which is the limiting reactant. Okay, once again, we are going to look at each reactant individually and compare it to a single product that they could form. In this example, I'm going to compare each of them to how much Fe3O4 could be produced. If I start with the 36 grams of water, I'm going to set up a series of conversion factors that will allow me to cancel out the units that I don't want and will leave the units of mole Fe3O4. As I look at my first conversion factor, it's a mole to gram relationship. I can get that information from the periodic table. 1 mole of H2O has an approximate mass of 18 grams. And then a mole to mole ratio is going to come from the balanced chemical equation. As I compare water to Fe3O4, for every 1 mole of Fe3O4 produced, I need 4 moles of water. Now, as I work through this calculation in my brain, 36 times 1 divided by 18 is 2 moles of water. And then to determine the amount of moles of Fe3O4 produced, I take that 2 times 1 divided by 4 and end up with 0.5 moles of Fe3O4 produced. Okay, now the second calculation we're going to do is we're going to look at that second amount that we're provided of our other reactant, in this case 167 grams of iron. I'm once again going to set up a series of conversion factors that will get my units that I do not want, in this case grams of iron, to cancel out until I get to the units that I am looking for, in this case moles of Fe3O4. Once again, the units that I don't want will cancel and I'll be left with moles of Fe3O4. Moles to grams, again, is a molar mass comparison that I can get from the periodic table. We'll estimate here again the molar mass of iron is approximately 56 grams. The relationship, however, between iron and Fe3O4 is not a 4-to-1 relationship, but a 3-to-1 relationship. Now this one is a little trickier to do in your brain, but hopefully we can still figure this one out. 167 times 1 divided by 56. Well, 50 about 3 times is 150, and 6 about 3 times is 18. So we're looking at about 168 grams there. So we've got about 3 moles of iron. And use your calculator if you need to, but you're encouraged to estimate. Therefore, times 1 mole divided by 3 means I will make about 1 mole of Fe3O4 if my 167 grams of iron completely reacted. So now let's compare the amount of our product that was made upon the reaction of 36 grams of water and 167 grams of iron. If the 36 grams of water had completely reacted, we would have made only 0.5 moles of Fe3O4. If we had completely reacted 167 grams of iron, we would have made a mole of Fe3O4. So obviously here, we make the smaller amount when we react the 36 grams of H2O. This indicates that it is the water that is limiting the production of our Fe3O4. As we look at the next part in this question, we are now asked to determine the mass in grams of black iron oxide that is produced. It's always important that you do this calculation based off of the limiting reactant, because that is the one that determines how much product we can actually make. Use my 0.5 moles of Fe3O4 that was produced from the 36 grams of water and simply convert that to grams. This relationship would come from the periodic table. I would need to take the mass of 3 iron and 4 oxygen. And if I do that, I get an approximate mass of 232 grams of Fe3O4, which means that I'm only going to make approximately 131 grams of Fe3O4 upon the reaction of 36 grams of water. Okay, now the last question here is asking us what mass in grams of the excess reactant remains when the reaction is complete. Well, now we're just going to compare our 36 grams of water to the other reactant, in this case iron, Once again, I will set up a series of conversion factors that will allow my undesired units to cancel out and will leave me with desired units, in this case, grams of iron. Again, when it's a mole-to-mole comparison, we go to the balanced chemical equation. For every 3 moles of iron, I need 4 moles of water. Grams to moles comparison comes from my periodic table. Again, I'm going to approximate the mass of iron to be about 56 grams. Now for this one, I'll use my calculator. We've got 36 grams of water times 1 over 18 means I have approximately 2 moles of water in that 36 grams, which means that I will take that 2 moles, multiply it by 3, divide it by 4, and recognize that I will need 1.5 moles of iron to react all 2 moles of that water. Again, pause here and recognize that we have a 3 to 4 relationship in our balanced chemical equation. In other words, I will only need 3/4 the amount of iron as water to complete this reaction. So if I need to react 2 moles of water, I'll only need 1.5 moles of iron to completely react it all. Our final conversion here will get that amount to grams. I take that 1.5 moles and multiply it by 56, the molar mass of iron, to get 84 grams of iron that would be used. Now be careful here, this is the amount of iron that is going to be used in this reaction. And the question is asking how much of the excess reactant remains. Well, originally I had 167 grams of iron. I only needed to use 84 grams of it, which means that 83 grams of iron remain unreacted. Boom, and we're done.